right. Hello, everybody. I'm Alexandre, production engineer at Facebook. Gonna talk to you about vulnerability management, how we're doing this on Facebook. And this talk is a mix of the history of how we made this thing happen with some ideas of the system that we built. And hopefully what I wish you take out of this is like, if you're having troubles in like building this program in your company or the companies you're working for as a contractor or as a consultant or as an employee, there's probably some lessons learned from this talk that you could take away. And also on the technical side, the tools that we built and how we built them and what do they look like, and also an interesting announcement throughout the presentation. So, like I said, Alex. Our team is actually called Production Engineering Vulnerability Management. The team, I'll talk about the team. Actually, now I'm realizing I don't have my notes. I'm so spoiled to using two screens. This is going to be interesting. Anyway.
You can put that in extended screen instead of mirror. Your notes will be there.
Let me do that then.
And you have no notes on
now?
your screen.
Yeah, I'll take this off.
You want me to redo your notes?
A second screen laptop there.
No, this will be fine.
If you put that in extended, you should have
load it on your phone.
Nah, too much.
If you put that in extended, once you connect the display, it should allow you to have the first.
I think I'm going to upload this recording raw. I'm not going to edit this.
That's fine.
You do jokes.
We're rebooting.
So, arrangement. Oh, it's not in mirror mode.
Then, depending on the app you're using, it should do that.
Yeah, it should automatically.
Yeah, let's
Depends
see.
on like
Let's
PowerPoint
see, let's
does
see.
that, Google Slides does that.
Yeah, let's see.
Uh,
Yes, this is great. This is what I wanted. Thank you so much. All right, so like I was saying, our team is production engineering vulnerability management. One very important distinction to make here is that we are basically production engineers. We're not security engineers. A production engineer at Facebook is like, there's several archetypes of production engineers. We're basically like software developers that can do sysadmin, but we don't like doing things manually, so we automate everything. It's like somewhere between DevOps, SRE, that whole gist. Our team is split between here in London and California. We have 4 people here in London, 3 engineers, myself included. I'm the tech lead of this program. And we have a manager here in London as well. And we have 4 more people, 4 more engineers in California. And 2 TPMs and 1 director to form this group. What's important here is that we managed to actually split the work in such a way that we don't block each other on each sides of the team. Like, we are autonomous enough here in London to build our stuff without blocking people in California and vice versa. And that distinction is like, some of the components of our system are owned by these different people, but we belong to the same team. A little bit of history here. This program existed in Facebook for many years. This started like long ago when a set of production engineers from P Security, which is our team, our broader team, they started building these things initially for compliance. They needed to deploy like network scanners for PCI compliance, payments, and things like that. But they liked doing this, so they also built a system at the time called Vulnmetrics. That this thing is like a widely distributed binary, runs on every single server in our fleet, which is like millions of machines. And this Vulnmetrics program was basically taking an output of like a list of RPMs installed on machines and other software and shipping this to our warehouse, where people could actually go in some internal systems and take a look at what those systems look like. And then over time, those people moved away, new people came in, people moved out, and then this program was like, we're running just compliance stuff until we needed to reboot this program. And this happened at the beginning of this year. January 2018, we had a whole reboot of this program. We decided to take this challenge further with a lot more planning. And then we started rebuilding this team essentially with 2 engineers, myself and Matthew, my peer, my partner in crime in California. So we started like having these ideas of like, first, how do we solve this problem for a company the size of Facebook with 2 people starting? So we needed to build something that would be like scalable enough, that would not make our lives miserable. We wanted to still have like a good on-call. We don't want to be chirped at night. It's just 2 people. And also, we wanted to scale on the people side of things. Like we needed to get more people working with us to be able to make this thing happen. So basically, our first 6 months from January to July, to June, we were basically like building stuff. And that started with some interesting components of our system. And that worked so well that throughout this journey of the first 6 months, we ended up like hiring more people. Some other folks from other teams were interested in the data that we were producing. So they started like joining and helping us build this system. And then today, I can tell you that we partner with at least 7 different teams in Facebook. And these people just came up like randomly. Some of them we needed to partner with them, and I'll talk about these partnerships along the way of the slides. But some of them just showed up because they thought that we were doing cool stuff and they were interested in security. One thing that is important to say too is that on Facebook there is nobody will tell you actually what to do. If there is like a VP or a director telling people what to do, they're doing it wrong. So basically, these decisions are made by engineers. We are trying to understand what are the problems that the company needs to fix, and we are trying to come up with these solutions. Our managers and directors are pretty much supporting us with hiring, with staffing, and helping get us connected with the right people in the company. But basically, the engineers are running the show there. And this team is no different. So let me talk about the system that we built. This is basically like any other system in vulnerability management, a massively big pipeline. It runs a schedule. We can run these things in our data warehouse hourly, daily, and then we produce these results at the same pace. This is built on common Facebook infra. But from the beginning, we were careful enough to not tie too much into Facebook-specific dependencies, so we could actually move these set of tools to different environments. And that would allow us to actually support all the Facebook companies, which includes WhatsApp, Instagram, Oculus, and Facebook itself, plus all the acquisitions, all the other weird infrastructure that people like decide to buy stuff on Amazon and run their stuff there. Our company is pretty autonomous, like everyone is very autonomous. And then even to find these systems, sometimes it's challenging. Like we learn, we have new software repositories, nobody knew about it, like from our group. Well, let's start plug this stuff into our pipeline. But then for more complicated cases, like there's been even talks of like, we have to hook into payments. If someone is expensing stuff to Amazon, we should know about it and go after them and things like that. The components in our system are pretty simple. Like we have a registry, and the registry part is basically like all the intelligence, everything we know about all of our systems. This is built here in London. This is our team. It's like pretty much 3 engineers and a manager. We got the manager to do all of the UIs for us, which is great. And I had to have that on record. The remediation side is basically the people in California. We obviously have some overlap in it, but basically they're running the show from California. And the reason they're doing that is because we have the 4 engineers there. One of them just joined. The 2 TPMs that we have, they have like contractors, and they have a partnership with other teams to help them get remediation going as well. So I'm gonna talk a little bit about like how we make that happen. In the portal is like a UI where you can actually see the data, all the data that we collect and process. So our software stack is sorted alphabetically, but basically all of our tools, the tools, command line tools and things like that, critical components of the pipeline, they're mostly written in Go. all of the UI and some of the systems that are strictly tied into internal stuff, they're written in Hack, which is our version of PHP, also open source. Python, because Facebook is a massively big Python shop, like to orchestrate our stuff in the data warehouse, we have to use existing systems. Those are all in Python, so we use Python, and obviously a lot of SQL. Like because we decided to build the system on the data warehouse, we end up like using a lot of SQL, which was interesting in the beginning because some people like that are not very used to seeing SQL coming to our team and looking at some 100-line long SQL queries doing matches and whatnot, people would like freak out a little bit. This is more common in other areas of the company, but not necessarily like in security or even in like production engineering in general. So I'll talk initially about our registry, what it looks like, and why we decided to build this. So if you think about the history that I just mentioned in the beginning, like we started with 2 people. We were like, if we start creating like agents and things like that run like in a bunch of machines, what if they break? Like we don't want to like be waking up at night to fix stuff because people change things. People are pretty autonomous on Facebook. Anyone can commit code to anyone's project. You can get some code. You have to have a code review and all, but people are generally pretty autonomous. So we thought like if we start building these things and just put them in the wild, this is not going to go well. So let's just build on top of a common infra data warehouse, scheduled stuff, which means once it's landed, once it's running, even if it fails, the data warehouse itself has retry mechanisms. So we were like on-call free, basically. For the first 6 months, we didn't need like to have alarms. Things would just run. We would just collect data and so on. So our pipeline looks like this. The initial part of the pipeline. This is the registry, right? So we have a set of collectors, which is interesting after watching your talk, Stuart, because I think you mentioned some of those things. I think we have very similar. We had very similar ideas. We just implemented them very differently. So we had this idea of like, let's start running collectors. These collectors are extremely simple programs. These programs are like scrapers and things like that. Their output is CSV, right? Very cool technology. People are talking like REST APIs, gRPC, streaming, and we're like, we just need to dump CSV so we can put this in a table, right? So we started going after these programs. And then our set of processors, we're like, all right, the input to these processors is what? Guess what? CSV. They take CSV standard in and they output CSV standard out. No big deal. And then we had like different sets of processors, and some of them will do normalization. I actually have slides for each one of these things, and I'll talk a little bit of them in more detail. And in the end, we end up with this inventory where we have all the known vulnerabilities in every single system that we have collectors for. This is one of the things that actually made our program and our system scale, both on people and partnership. So let's go through these collectors. So network scanners. Network scanners are basically these black box equipment. We buy them or hire these companies to provide them for us. Basically like what everybody else uses, like we have Nexpos, Nessus, mainly for PCI compliance. We don't, today we don't run them like very broadly in the infra. We focus only in there, and that's where they started. We might start using them for other things, but because in our data centers, outside from our, even in our corp infrastructure, but basically we use IPv6 everywhere, which means you cannot use network scanners for discovering stuff, right? You cannot like just blindly scan IPv6 networks. That's not going to fly very well. So the way we orchestrated these things is like we get ARP dumps from switches. So we actually see all the traffic that are going through the switches. We get dumps from those tables, and then we use that to trigger the network scanners. That can help us find services that are misconfigured, like someone is running some lab, whatever, Tomcat default password, things like that. It would catch it. But it's not our like primary focus using the network. Like we might go back to trying to do like white box, do some experiments with this next year, but this year we have no plans to expand this infrastructure. It's just there collecting data, and this one in particular ships data straight to the remediation pipeline, which is coming in the next slide. So software repositories, we knew from the beginning, and this is something that they didn't try in the previous versions of this program. We knew that the source of the most problems in our infrastructure is third-party software, like everybody else. And we actually host a lot of these softwares. I would say, I don't think you can actually just randomly download something and use that to build a system. You actually have to land your code. We obviously have several different repositories where you can land third-party software. And the reason for that is like, if you're working in the infrastructure, you have a set of tools. If you're building like mobile apps, you have some other set of tools. And those use different repositories for third-party software. So we were like, let's try to put together a list and write collectors for these things. So back in January, it was pretty much me and Matthew lining up like, this is the list of repositories we have. Let's just be practical. We have like Maven, for example. What do we do? Let's read how the Maven API works. Scrape Maven, get the list of our packages, dump CSV out. And then we have this other repository like with internal software. Let's just scan it. So whatever the API they have, scan it, dump CSV out. So we just created these programs which were like initially very easy to write, very easy to test. But we had a challenge with that. It was super hard to hire people telling them, oh, you're going to write some tools that output CSV. And people are like, I didn't join Facebook for this. Like, you know, I want to work on like bleeding edge stuff. Yeah, I know. At least it's in Go, right? We actually had troubles because of that. Like one of our collectors, like the Maven one, was scraping it so fast that we actually cracked Maven a few times, caused issues in the infrastructure. We had to put sleeps in the code to make it do it at a pace. So basically, that gave us like a lot of good coverage on software repository sides. And these repositories, you also have to understand that like because our coverage is not just the production environment, it's like the entire company. We also built in partnership with the other teams, like teams that take care of like employee laptops, for example. They have their own software repositories where they actually ship software to our Macs. Same thing for our mobile phones, right? So we use like Mobile Iron, which is like common product, and we hooked into the Mobile Iron API so we could actually know apps installed on employees' devices, and then we would ship all of that to the warehouse. So basically we spent 6 months writing these programs and trying to convince people that it was cool to write CSV. It was hard in the beginning, but after we actually mapped this whole thing out and we had like our entire project lined up as tasks, and then when people would come in, we had this massive graph and it would say like, this is what you're working on. This is the CSV tool that you're building, but this plugs into this massively entire system. And then it would make it much more interesting because they could actually see the big picture.
So is this program itself and all its collectors crossing bridges of all these different networks and repositories?
In some cases, for two or three of them, we actually had to poke holes in the firewall to let these things collect stuff. But for the vast majority, we actually run them close to where they need to collect. And they have different mechanisms to ship data back. So at Facebook, we have pretty common systems in the infrastructure for a message bus, for example. There's like one that everybody uses. And if you're off the network, off the data center network, we have like graph APIs and things that you can use to access those things. So if you run the collectors outside, you can actually use those APIs to ship data in. So it's not too bad. And obviously, because we're in security, we don't want to make it like so bad. In terms of agents, we decided to use agents. Von Metrics that I mentioned in the very beginning was an agent. Like we run this on every single machine, but we also run many other agents on these machines. We even have this thing called the FB tax. Every time we have a new server in the data center, it comes with like 100 services already, like, you know, things that... And then we're trying to avoid this. So we decided to just reuse common infrastructure. One of the agents that we have in all machines, including our laptops, in the corp side of things, and in the data centers, in all the servers that we own, is OS Query. We use OS Query to look at our systems with plain SQL, which is very well aligned with what we were doing. So basically, we went to the OS Query team. We partnered with them as they were transitioning to London, made things a little bit easier. We basically created a set of queries that we wanted to use to inspect these machines. Like, oh, give me a list of all Python packages that are installed on these machines, all RPMs, all Docker images that you see in these machines. Created that set of OS Query queries, landed that in everywhere in all machines, and it started collecting data in the warehouse. So boom, job done. And some of them are more colorful. Like for example, our container infrastructure is called Tupperware. You can actually watch talks about how Tupperware works and so on. But to get the data set of everything that is running in Tupperware everywhere, every day was slightly challenging. And that one was Thomas. This guy actually did that one as he was joining the team. So basically he had to do shenanigans, like collect data of like containers that are coming up and down. And then by the end of the day, get the data from all the container jobs that we know that are running, go to the scheduler, hammer the scheduler to get the spec of them, so we could actually know all the packages, what the images are made of, and so on. So some of these collectors were easier, some more complicated. And then one special type of collectors we have, we call them providers. This is where I actually get vulnerability databases from. NVD is in here, for example. For this, we created a tool called, everybody has a VulnDB, we have one too. We have this tool that actually has a versioned data from providers, from upstream providers. So basically, every hour, fetch data from NVD, import to our VulnDB, and then we have other vendors that we use to get this data from, import it in there. And the reason we did this is because we wanted the processors to use data from a single source. And because many people in the company show up with like, oh, can I use data from this provider because they have data from, I don't know, Juniper, right? We're like, yeah, sure. But to avoid confusion and a mess, we actually decided to go with the industry standard format from NVD. We started with the XML feeds, and then we recently transitioned to using their JSON feeds. And to do that, we actually had to build tools. Some of them are even on my GitHub. I had to build like a code generator to understand the NVD JSON schema, so you could actually generate Go code and Thrift code, which we could use in any other language, and so on. So we built that, and on top of what that gives us is like the ability of actually creating overrides for some of the CVEs. I don't know if you had the time or looked at the data from NVD. A lot of it is pretty good, but a large chunk is really messed up. Right? There's a lot of like CVEs that point to CPE software that have the version as a star, like all glibc is vulnerable. That can't be true. All macOS is vulnerable. That also can't be true. So with this tool, we could actually edit existing data from the vendors and save them separately as overrides. So we could go and tweak this data so our processors would actually find correct data and avoid finding false positives. We might open source this tool. It's generic enough that we could do this. It's just not happening right now. On the processor side, we have several different types of processors, and one of them, the most common of them, is like normalizers. We have, because the way our collectors work, they land data in several different tables in the warehouse, and these are like, think of this like Hive data warehouse, a bunch of massively big tables. These normalizers just go there and say, oh, hey, look, we have 20 different tables from these collectors. Let's normalize them all, which means get the data that we know from all these tables, get the columns from these tables, which contain like the software name, the software version, the vendor of that software, patches, and so on, normalize to a standard data set. We use the NVD CPE format for that. We normalize all of that, land that in some other table, and then in that table we have like all the software we have in all software repositories in a standard form that feeds straight into the next set of processors. Then we have these aggregators. These things are like joining data from multiple tables so we can get more information from them. We also use this to actually build metrics from everything, and also to build data that backs our portal. Things that people actually see. Like for example, if you want to see all the software, regardless of vulnerabilities, all the software inventories that we have for a particular team or for a particular org or for a particular group in the company, if you would say like, what is like all the software used by the people that actually work in the data warehouse, we actually have that. So yeah, aggregators, another set of processors. And then the vulnerability discover processor, this is the one I wanted to mention. We are in the process of open sourcing this one. And guess what? The main tool in this package is called CPE to CVE. And the one that you use to feed into this is called CSV to CPE. So you take some CSV, you say, in this column I have a software name, in this column I have a version, in this column I have a vendor, architecture, x86, ARM, whatever. and then that builds a CPE for it, and then you pipe that into CPE to CVE. It uses the JSON feed from NVD that we usually get from VonDB, from our VonDB with our overrides, blah blah blah. Dumps more CSV for all the CVEs that we have, and it's pretty simple, scales well. You know what's funny about this? When people started looking at this stuff, random people, we got like people from WhatsApp coming to us, and also people from Instagram like, hey, can we write the collectors for our system? We're like, yeah. How complicated is it? It's like, can you dump CSV? Oh, we're in. So that actually helped our program grow massively. Like random people coming up and say, if I land a collector here, can I get CVEs out of the other side? It's like, yeah. They're like, oh, I'm in. So they started joining this. So we managed to actually scale, and then because our managers and directors started looking at this, they're like, oh, this is working. So they started hiring more people to help us build more stuff. And then
so inefficient at some point.
Sorry?
Sounds so inefficient at some point.
You might think so. It's actually the opposite. If we were building super complex systems, with like streaming APIs, well, it would be much more complicated for people to actually orchestrate this. You have to think that we started this with 2 people, right?
Yeah, exactly.
And we were running this, producing data by the billions. Right, so we're like every day we're producing like billions of records with the entire inventory of everything we know about the company, and without having like a horribly bad on call, like our systems are not breaking. If things fail, and they do eventually, like some table of the data warehouse is unavailable right now, it's gonna retry next hour. So life goes on. We keep going. There's not a lot of like miserable life trying to troubleshoot. And when you're troubleshooting these systems, you can actually just go there and run the thing on your machine. If it dumps CSV out, you're good, right? In the end, a lot of us in production engineering are super hardcore Unix people, right? We like simple things. We like these composable tools. And for this, in many other cases, we think like a text interface is good enough. We don't need to overcomplicate this thing. Right? Is essentially when you're running like a pipe on your machine, bash pipe this, pipe that. We're just doing that like at scale, like with massively big amount of data. We had this interesting conversation today. We were talking about like some of the limitations we have, like in MySQL, for example. And a person in our team mentioned that, when you talk about like big data, MySQL is far away from that. Yeah. Those command line tools that we use, cat, grep, they're much closer to big data than MySQL. So keep that in mind. These are simple things. They scale well, right? And you can build on top of them over and over, and they won't like let you down. When it comes to remediation, this is where our inventory, the work we do mostly in London, that's where we stop-ish. Not really, but I'll talk more about that later. And this is where the people in California pick it up from. Like we have already these data sets, everything has landed in the warehouse, we have the full inventory of everything. Now they have to go and look for what do we want to fix and how do we actually orchestrate the fixing. I'm just going to make a pause and give one of these away to... Yeah, this guy's been asking.
Thank you.
So this is what it looks like, roughly. It starts from the inventory. We do what we call decoration. And decoration is a common term that we use to like augment data, basically, right? We have information about these set of software. It belongs to a machine. Who owns this machine? So that's called decoration. We go to some other system, fetch that data, join that. Sometimes it's just SQL. Sometimes you actually have to write a tool that will like take some CSV and do shenanigans, edit the CSV, add a new column and so on, and then land that in another table and we keep going. The decision tree is like, how do we make a decision of what to fix? It's really important in this part of the system to understand the release cycles of every single system we're trying to remediate. If we don't know the release cycles of these systems, we're going to be super frustrated. We're going to give tasks to people, or we're going to try to help automate the systems, which is pretty much impossible for a group of our size, try to automate everybody else's software. So we have to understand the release cycles, which means sometimes if a vulnerability makes it into their systems, and they can make this in several different ways. One of them is, for example, you have one of the third-party software repositories has a library there, and then we use that in our infrastructure repository. We have some common libraries that use that third-party library, and then 100 people build their systems using our internal library. They don't even know that they're using third-party software. And when they run those 100 systems in thousands of containers, we have a much bigger problem, right? So what happens is, if we go back to that repository that we have in our inventory and we fix that, how long does it take for the fix to actually propagate? And what do we do with the long tail, right? So understanding the release cycle, most of the time, the action that comes out of this is just wait. We even have that functionality, we call it as news. Like, yeah, we know that these systems have automation, that they will like roll out a new version in up to 14 days. So it's, you know, if it's not critical enough, this thing should disappear. And if they don't disappear, then we move to the next phase. Also, if they're like complicated enough that, or they don't have automation, then we go to the next stage of the pipeline. And tasks, I actually mean two things by that. We have a few different tasking systems inside Facebook. The most common one is literally called tasks. This is what everybody uses. Like, you're gonna do some work, you create a task, you're gonna write some code, you create a equivalent to a pull request, but you associate to your task. This is, think of this as GitHub issues and pull requests. We have tasks and diffs, basically. That's one, that's the most common. If you give a task to anyone in the company, they know what it means. We also abuse the task system. For example, we created a task for our manager to buy a bar for us to put in the office. So people are used to these different tasks. Like this is like some activity task. This is some like work task. And the other system we have is called SRT, is a proper ticketing system with history and so on. But that one is not widely used by engineers. That one is actually mostly used by people in security that work in incident response, work in detection. Those things actually create cases that people go and look at. So we also integrated that system for cases that we don't know what to do. And then we have a group of contractors that are looking at those cases and talking to the teams that own those things. For example, the OS team. Like if we find something in a package that is like in the base image of all the OSs, we actually create a case for that. An analyst actually looks at that case, talks to the people from the OS team, they get the remediation, tell that to the system, and we see that metric go down in the next release cycle. So that's pretty much how we orchestrate it. These decorators, like I was saying, they basically add more information. These are very similar to processors. We might at some point move them back in the pipeline and do that in here. But basically, they are like, they already have all the data. They're assigning ownership. They're assigning upstream status if we know, like, oh, this software has a vulnerability and people are using it. What is the status of the upstream version? Is the upstream version better or worse? If we do the upgrade, can we see this propagated infra? So decoration is that. And also, we've been recently assigning labels to these things. Think of labels, how people use labels in Kubernetes, so we can actually search for them. A label would be like a domain. A domain is like the corp environment or the production environment. A domain would be like WhatsApp. So we can actually query and see what are all the vulnerabilities that we know about this particular domain. And then we can use this tagging system as well, the label system, as tags. Like, for example, we know that our processors are finding this vulnerability, but we actually patched the software. We just didn't update the spec, so our system doesn't know. So we can go there and assign a label, say, snooze this, like, this is going to be fixed. And you can put a deadline, like, make this label exist here for up to, like, 2 weeks. And after that, our system is going to find it again, and someone's going to have to do something about it. The decision tree is, like I was saying, basically is like most of the time is to identify who owns this problem, to understand the systems that are using this vulnerable software or hardware, and what to do about it. The worst case scenario, the last resort is tasking people, basically. And this can also trigger automations like, oh, reboot this machine, kill this container, it's going to come up somewhere else. And then the output of this decision tree basically decides what these things to do. And then tasks, yeah, that's our very last resort. We don't have enough people to fix everybody else's problem. And we've been even investing now in gamifying these things. It's like, if we identify the ownership as like, if there's a third-party software that is used in the infrastructure by 1 or 2 teams or people, they are clearly the owners. If it's in between 5 and like 10, you can, create a task to them and try to get them to fix it. If it's a common package that a bunch of people use, we try to crowdsource that. Basically create a task that has all the information about how to fix that system, and whoever does that gets stuff. Like get budget, travel, whatever. We can offer things, like we have budget to help get people fix the company, common infrastructure that nobody has time to think about. We just go and gamify this stuff and give stuff to people so they actually engage more with us. One interesting case we recently had, me and Thomas, we were looking at some, random vulnerabilities like that are not super high in score. We found recently like libdwarf has a bug in dwarf dump for elf binaries that we don't use actually, but we actually use the library. And then we fixed that in the repository. When we put up a diff to actually update that to the common repository in the infrastructure, guess what? A load of systems use that library. And then some of the builds start failing. We were bumping like 15 versions, right? So this thing was last updated 2016. Then when we updated, it was like, this is not easy, right? This is what actually normal people that get those tasks, they actually have to do. Like you first learn how to use this repository system, fix that, propagate that to the common infrastructure, and then that's where you hit the most problems. And then eventually you're going to have to patch some other random systems that use that library. And Thomas did that with HHVM, our production customer-facing web server. So he's now an official committer because it was fixing a vulnerability, just fixed that. It got approved. Eventually it's going to be in the release in the next few weeks. So our main philosophy is like we cannot fix all the things, but some of the vulnerabilities, if they have like high enough score and risk, we basically go and fix ourselves. But that's not our goal. Our goal is to actually build the tools. We feel responsible for like not having those vulnerabilities. So basically our motto is like common in the company. Yeah, it's like this is broken. This is not nobody else's problem. If we know how to fix it, let's just go and fix this and life goes on. If it breaks someone else's system, we are going to help them. We're going to partner with them. But eventually what we all want is to get things fixed. Like I was saying in the beginning, maybe we're too spoiled because this whole thing is run by engineers. So, we just go and talk to others. There's nothing like top down. No manager is going to tell you, oh, go do that or don't do that. We just go and do things as we please.
How much of these fixes do you guys upstream? Everything, just part of it?
Yes. So we try, like we had this weird case where we've been trying to fix like libvorbis, for example, this pull request for like a year. They don't take it. So, we keep our internal patches. Ideally, everything that we fix, and we've been talking about even fixing the upstream databases like NVD, for example. A lot of the vulnerabilities in NVD that are somewhat broken, we find them because our system is discovering, generating false positives. People are looking at them and fixing those things. We've been even talking like we recently got the CNA, we can actually submit CVEs and all to NVD. So we've been talking like how can we help fix that database as well, which is completely outside of our org, but we get the benefit. And we've been even talking to other companies in the industry that we could maybe like partner somehow to help fix that database because we all use it anyway. And then, some notes from this. This is my last slide. It's like, this story tells you something like make it work first and then you make it right. Like in the beginning, we were like, simple programs, just run them. Some of them are running in some random machines cron tab before we actually moved it into a proper pipeline. Make it work first and then you make it right when you have the people. So start easy, start showing results, and if that's working, then you go and do some redesigns, V2, whatever, of these components, not the entire thing. The entire thing I think we got right from the beginning. And then, over like, why do we need like complex like RESTful APIs, blah, blah, blah. People, we're just moving data around. We just want to find bad data, right? So it's basically like, you just move this back and forth. It's just a pipeline. There's nothing, no secret here, no rocket science. And then prioritization of the remediation based on risk. When I say risk here, I'm not just talking about the vulnerability themselves. It's like we can have a very critical vulnerability in software that exists in 2-3 services inside of an infrastructure that nobody has direct access to. But we can have a vulnerability of like score 5 at the edge. That's much more problematic. Or we have some vulnerabilities that are in the production environment, but they're exposed to all employees via the corp to prod barrier. That's a much higher risk than having some very high vulnerability deep down in the infrastructure, right? So use that to prioritize the fixes. And then this is a very hard problem. The HHVM example is a good one. Like you're fixing some random library that you found a bug in, and to try to actually land that fix in your environment is very complicated. You're normally affecting bazillion of systems in our case. And that's a challenge for us. So ideally, what we want, we've been partnering with a bunch of teams, and one of them are responsible for getting people into automation. We have different levels of automation in our infrastructure. Some teams have nearly no automation. They release things when they feel like, right? Because they're like starting up a new team, they're experimenting with stuff. And then we have those in somewhere in the middle. They have like a continuous build, they have continuous packaging, but their push to production is still a one-button click, right? And they do that like their own call, like every week or every 2 weeks, because those systems might be stateful. Someone actually want to look at that thing deploying, and if it fails, they will actually want to roll back things manually, and so on. So there is those cases. And then there's the good case where it's like full automation. You land code here, your code gets tested here, it gets deployed there, gets some shadow traffic, gets some tests, run there for a week, and if everything is great there, then they move to production. Those are great for us because we know that if we land a fix, we're going to see that in the other side of the pipeline. And therefore, because of this whole thing, these multiple levels, this last item is the most complicated for us. And, you know, teaching people that being security first, we don't want to block people from doing stuff. We don't want to lose credibility. We don't want to give them false positives. What if we start telling people like, hey, go fix this CV in this library? They're going to look at it and they look, oh, this is a version star. Like this is matching anything. No matter what I do, this vulnerability is still going to be there, right? We don't want to do that with people because we lose credibility. And as production engineers, we will never let that happen. So these things are complicated. Now I'm done with this. I'm happy to answer any questions. Thank you very much.
How do you deal with sensitive data? You collect so much data. At some point you'll have, I don't know, tokens that are collected, PII from some devices. How do you deal with that information?
So in the data warehouse, our systems are separated by namespaces. So we have several different namespaces of where we store data, like a namespace for ads, a namespace for infrastructure metrics. We use the security namespace for this. Only a subset of people in the company have access to that namespace. That's how.
I'm curious, you mentioned Postquery as one of the mechanisms for collecting information.
It's one of the collectors, yeah.
I might be wrong, but I seem to remember one of the more recent announcements from Postquery team was that it was going to become more extensible in the kind of data collection that you could do within Postquery itself, assuming that.
Yeah, they're evolving that system crazily.
Do you think that's a potential path for, like if you were starting today, would you continue with the approach of building individual collectors like you have done, or would you look at extending Postquery so that you had the one vehicle with just different ways of plugging in queries?
Okay, maybe I didn't sound correct with that message, but basically the collectors that we build, like the custom collectors that we built, those are things that only scan repositories, software repositories. Right. Those are pretty like a small set of like, oh, we have like 50 repositories. Let's write one program for each one of them.
Okay, cool.
Those are like for static things at rest. Yeah. OS query is like for everything that is running.
Running on the machines, yeah.
Running on machines. So that's the only collector we use for things that are running. Yeah. Nice. So I would stick to OS query still.
Use third-party tools, vendor tools for your vulnerability scans, or how is it all in-house built?
What kind of vulnerability scans? The discovery? No, we built a processor and we're open sourcing it.
Yeah, but you did mention using
Yeah, CPE to CAVE. Yeah, great.
Make CSV great again.
one more question, I guess.
I think so do you know there are tools already out there that probably does the same thing that you do, like Snake, and are you planning to plug that into your system as well?
Yeah, we actually been talking to Snake for quite a while, and we use their data set, not their tools. The reason is because a lot of these companies, like SNCC, for example, their main audience is like people running stuff on GitHub, on Jenkins. They actually run at build time. We cannot do that today. We can, we just don't want to. Like our system is running several thousands of builds per day. At any given day, we're talking like a lot of data. We don't want to add more tools in that pipeline, in the build pipeline. We actually prefer to let people land stuff and then we will find them, right? Our system has several layers of security. The vulnerability management program is basically targeting vulnerabilities at rest. Things that exist in libraries, things that exist in software, they're just there. Things that are like more on flames, like, oh, a new meltdown. That's a problem for the detection team, right? That's a problem for the CERT team. Vulnerability management, we're basically trying to get rid of vulnerabilities that we can find that are in software that nobody knows, and then we want to remediate them and get rid of them. We're not on the hunt for like, oh, this is on fire. So yes, we've been talking to those companies. We even talked to SourceClear back in the past, and they all have the same kind of tools. Like, oh, you know, you have a GitHub repo, put this in your Travis or whatever. Every time you send a pull request, it's gonna run the tool. That would never gonna fly for us. Like first, some of our code changes are like massive enough. A lot of them are basically just a first-party code, and then even to identify. Vulnerabilities that are coming to our infrastructure because of a third-party library, we actually had to partner with the ProdSec team to do static analysis. And because we use this monorepo, the way we built this thing is basically we look at the build system, the system you're trying to build, which is normally like a package, right? From the package, we identify what is the source code of that. From that source code, we do the reverse dependency graph. We find the third-party library, and then we associate back to this whole chain. And we say, this package is vulnerable because of blah, 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 blah,
See,
blah.
this is exactly the conversation I had with the guys from SNCC, because what they do is they can probably raise false positives.
Yes.
I'm not
So-
saying they do, but probably they do.
Yeah.
Uh,
So,
Would you be interested in augmenting your CPE to CVE system with additional data to find the vulnerabilities that you're not finding?
oh, so yes, what I was saying is like in our providers part of the system, we built this thing, the VulnDB thing. It's actually a multi-vendor database that we put data from NVD, and we decided to go with the industry standard NVD format, which means like even if we're getting data from SNCC or whatever, we actually convert them to the NVD data set and we put that in our database. So we might have to fill up like base core and some other information, attack vectors and whatnot. We put it in there. So when our processors run, they actually export that data with our overrides on top of it. And then the processor, the CPE to CVE, actually uses that. So it does support multi-vendor.
So we should, I'll come catch
That's
you.
fine. We can talk offline. Yeah.
Yeah, no, it's just that we can certainly help with all the stuff that you don't have.
That's great. Yeah. The one thing that I found is like in the NVD data set, you have like the common base of set like base tools, blah blah blah. You don't have a lot of like Node.js, and we've been partnering with other companies to actually get that data from them. The problem is every time we go talk to some of these companies, they have this entire system with UIs and blah, blah. That doesn't work for us. We're much simpler actually. I'm like, can I just have the data set? Sometimes they're shocked because like, oh, do you just want the database? Yeah, I don't want any of the tools. We have the tools and we're going to open source them. We just want the data set, right? So yeah, if that's the case, we should talk. This guy gets it. Take the book. Take the book.
Thank you.
All right. Any more questions?
Have you also tried to use NPM audit, or do you guys already have that data in some form?
Yeah. No. No. Yeah, we tried several different things, and you know, this journey is 1% complete. Like we just started. Yeah, we just started. Yeah, yeah.
The surface.
Yeah.
How do you keep all this data? All this collected
Oh, so the way our data warehouse works is like tables have partitions. Partitions can be hourly or daily. We normally keep like default, if you're just like writing random stuff, it's like 90 days, right? And you have a full snapshot of the entire thing for up to that retention. That we're spoiled.
Building all this information,
Hmm?
are you finding that you're finding like a league table of the worst ones out there?
Sorry, I couldn't get it.
So you know you're building all this information, vulnerabilities, and you have all this history. Do you find that you can build a league table of all the worst offenders out there as you get these updates, like from various people, various libraries? Are you finding that? Like,
Yeah, so that's part of like in remediation, part of like grouping that data, right? For example, and the portal also helps with that too. The portal is like some higher management level view of the thing. So if someone has wants to ask the question like, what is the situation of the Messenger app? They can actually answer that question from the portal because we have those aggregations per team, per service, per service discovery tier. You know, we have that information aggregated in several different forms.
but this is about the actual libraries that people are using, like if they're pulling in libraries from.
Oh yeah, that's actually how when we are like on the hunt, when we're like, oh, let's look at something, we just look, what is the worst library that has the worst vulnerability, like an RCE, that spreads to the most number of containers. So we get that one and try to fix that one. So yeah.
You want, Raj? Well, it's kind of, yeah, thinking about it, yeah.
You just need CSVs.
Don't give him the
You can call sort on them, literally, I'm just saying. Big data.
don't give him the CSVs. Might use it for something else.
All right. We good?
It's cool.
Thank you very much.
Thank you.